Welcome to Module 3, Ratio, Proportion, and Variation. Variation. So variation is a mathematical function that relates the values of one variable to those of other variables. So we have two variables, and what is the relation of that two variables? So there are three types that we are to consider. Number one is the direct variation. So under direct variation, when let y be a function of x, and under direct variation, we can say that y is proportional to x, or same as y varies directly as x, or y is directly proportional to x, or y varies as x. So all these four statements mean the same. So this is an expression of direct variation. So if we are to put this into equation, that becomes y is directly proportional to x. Or if we want to eliminate this alpha sign, then we will be introducing, so notice that the alpha sign becomes equal. So in order for this alpha sign to become equal, we will be introducing k, and k is a constant of proportionality. So the idea when we say direct variation, again, we have two variables. We have the variable x and we have the variable y as shown in this graph. And the direct variation, directly proportional, means that as the values of y increases, the values of as the values of x increases, the values of y increases also. So notice that we have here your x1 and y1. So if we increase the value of x1, which is x2, the value of y increases as well, and that is y's of 2. If we increase the value of x to this point, which is x3, notice that the value of y3 increases also. So that is direct variation. As the values of as the values of x increases, the values of y increases also. As the values of y decreases, the values of as the values of x decreases, the values of y decreases also. All right, so let's take a look some sample problems. So the circumference c of a circle varies directly as the radius r, because c is equal to 2 pi r, where the constant of proportionality is 2 pi. So again, we have here that phrase, the circumference c of a circle varies directly as the radius r. So if we are to write that into equation, that becomes c varies directly or is directly proportional to radius, because c is equal to 2 pi r, where the constant of the proportionality is 2 pi. So again, the constant of proportionality is the value k, or the variable k. And to eliminate this alpha, this now becomes c is equal to the constant of proportionality multiplied by r. But from the equation, or from the statement, from the problem, it says that the constant of proportionality is 2 pi. So substituting, that becomes c is equal to 2 pi, the constant of proportionality multiplied by r. So therefore, the statement is true. It says that c is equal to 2 pi r. So napalabas natin, na-prove natin itong 2 pi r. Number 2, if y is proportional to x squared, then y is equal to kx squared. So again, if we are going to write this one, so the q here is proportional. The variable y is proportional to x squared. That becomes y is proportional, or directly proportional to x squared. So para ma-eliminate natin yung alpha, this becomes y is equal to, we introduced a constant that is k x squared. Next, the last type of the variation is the joint or combined variation. So let z, this time we have a third variable, that is z. Let z be a function of x and y variables. Then we can say that z varies jointly as x and y, or z is directly proportional to x and y, or z is proportional to x and y, or z varies as x and y. So again, these four statements mean the same, and if we are to put this into equation, this becomes z alpha xy, and this is read as z is directly proportional to x and y, or z varies jointly as x and y, or z is proportional to x and y, or z varies as x and y. So again, if we want to replace this alpha sign into equal sign, we will be introducing a constant which is k. So it can be written as z is equal to kxy, wherein the constant is introduced and then the alpha sign is changed into equal sign. So k is a constant of proportionality. So example, to say that z varies directly as x and y, and inversely as w2 w2 means that so if we are to put that in equation, we have here the first one is varies directly, and then the other one is inversely. So again, let's first deal with the first relation, varies directly. So z varies directly as x and y, and inversely as w2, and inversely as w2. So again, let's eliminate the alpha sign. So we will be introducing a k, and that simply becomes z is equal to k xy over w2. So this is now our answer. Next, p is equal to 10x squared multiplied by y divided by z cubed. So we have here an equation, and if we are to translate this into its variation, into the statement of variation, then we can say that p varies directly, so as x squared and y, and inversely as z cubed. So again, the numerator part is this one. The numerator part is varies directly, and then the denominator part inversely as z3, or this should be z cube kasi z cube siya doon, so this is supposed to be z cube. Okay, so this one z cube. So again, this equation p is equal to 10x squared multiplied by y over z3. We can say that p varies directly as x squared and y, and inversely as z cubed. So 10 here is the k, or the constant of proportionality. Alright, so let us now consider some problems. Number 1, n is inversely proportional to the square of x, and when x is equal to 2, n is equal to 50. What is n when x is equal to 5? So the first thing that we are to check or to find is to see what kind of relationship the statement is saying. But for this problem number 1, we have no problem because it already says that it is inversely proportional. So the next thing that we are to do is to put this into equation. So n is inversely proportional to the square of x, so that becomes 1 all over x squared. So again, sabi natin, if we want to change the alpha sign into equal sign, we will be introducing a constant, which is k. So that becomes n is equal to k over x squared. So next, when x is equal to 2, n is equal to 50. So when x is equal to 2, n is equal to 50, we will be able to solve the value of k. So let's substitute. N is given to be 50. and then our constant k, and then x is given to be 2. So that is 2 squared. So substituting, k now becomes 50 times 2 squared is 4. So k is equal to 200. The next, what is n when x is equal to 5? So when x is equal to 5, k is equal to, or that is n, is equal to k over x squared. So n now becomes, we know the value of k because we were able to solve it. So that's 200 divided by x is 5, 5 squared. Therefore, at n is equal to 8. So at x is equal to 5, n is equal to 8, and that is now our answer. Next problem, the electrical resistance of a cable varies directly as its length and inversely as the square of its diameter. If a cable 600 meter long and 25 millimeter in diameter has a resistance of a 0.1 ohm, find the length of the cable 75 millimeter in diameter with resistance of 1/6 ohm. So since there are a lot of variables or numbers that were given, let us identify each given so that it would be easier for us to solve the problem. So again, we have here your 600 meters, and that is length. We will call that as length 1. So length 1 is equal to 600 meters. And then 25 here is diameter. We will be calling that as well as diameter 1, 25 millimeters. And then at the same time, the resistance is given. So R's of 1 is equal to 0.1 ohm. And then find the length of the cable. So L2 is what is unknown. What is required? We do not know. So that is the required that we want to know in this specific problem. And then we have here 75 millimeter. This is your diameter 2. And at the same time, the resistance is also given, that is equal to R's of 2 is equal to 1/6 ohm. So by merely just plotting the given, we already have an idea, or we have a bigger or a clearer point of view on what are the given and what is the unknown. So again, next, after plotting all the given, we have to check what is the involved relation within the statement, and we have two. One is varies directly, and we also have inversely. So the next step is to put this statement into equation. So let's do that. The electrical resistance of a cable varies directly. So we have here R, electrical resistance of a cable varies directly as its length and inversely as the square of its diameter. So as and inversely as the square of its diameter. So we have here our equation. So again, for us to eliminate this alpha sign, we will be introducing a constant, that is k. So that becomes R is equal to k multiplied by L divided by diameter squared. So we will be able to solve the value of k using the first set of the given. So we simply substitute the given to this equation. So R is equal to, our R is given to be 0.1 is equal to the constant we are trying to find multiplied by the length. Length 1 is given to be 600 divided by diameter is given to be 25, and that is squared. So k is equal to, simplifying, this becomes 5 over 48. So our value for k is 5 all over 48. So since we already know the value of k, we will be using the same equation, but this time We will now consider the second set of the given. So again, R is equal to KL divided by diameter squared. So R is given to be 1/6. So substitute is equal to K is 5 over 48, the one we were able to solve, multiplied by L's of 2, which is unknown, divided by diameter 2. So diameter 2 is given to be 75 squared. So simplifying this, we come up with L's of 2 is equal to, so let me just calculate that, 1/6 times 75 squared times 48 divided by 5. So L2 is 9,000 meters. So that is now our answer. Okay, so again, let's wrap up this problem. First is we have here the problem, and then the first things first is we have to identify all the given. So especially if there are a lot of numbers that is given in a problem, the easiest way is to list all the given, and the next is we formulate the working equation. So we came up with how did we come up with this equation? We checked the relation. So it says in the problem that the electrical resistance of a cable varies directly as its length and inversely as the square of its diameter. Thus, we were able to come up with this equation. So again, we will be introducing a constant so that the alpha sign will become an equal. And then from there, from the first set of the given, we were able to solve the value of k, which we used in the second equation, in the second set of given. So in the second set of given, L2 is unknown. We will be using the same equation. K is solved, R is given, diameter is given. So eventually, we are able to solve for the value of the second length, or L's of 2. Okay, so that is the problem.